Let's see what happens when we divide powers. But first, let's make sure you're comfortable multiplying them. If you have 4 to the 5th power and then multiply it by 4 to the 3rd power, you'll get 4 to another power. What's the value of this exponent over here? Right, you can add these exponents. So 3 plus 5 is 8. So 4 to the 3rd times 4 to the 5th equals 4 to the 8th. Now let's try dividing 4 to the 5th by 4 to the 3rd. Well, 4 to the 5th equals 4 times 4 times 4 times 4 times 4, a total of 5 4s. And we're dividing by 4 to the 3rd, which is 4 times 4 times 4. You can cancel out a whole bunch of these 4s. To simplify this fraction, why don't you select which 4s you would cancel out? Exactly, so there's lots of cancellation. The 3 4s in the denominator here will cancel with 3 4s in the numerator. You could have picked any 3 4s in the numerator, like these 3. So after canceling out all these 4s, 4 to the 5th divided by 4 to the 3rd equals 4 times 4, which is 4 raised to what power? Great, so 4 to the 5th divided by 4 to the 3rd equals 4 squared. You can think of this as starting with 5 4s being multiplied together, and then you're canceling out 3 of them. And that leaves 5 minus 3 4s that you're still multiplying together. So this exponent in the answer is 5 minus 3, or 2. Let's double check our answer to make sure it's right. 4 to the 5th is 1024, and 4 to the 3rd is 64. If you check on your calculator, 1024 divided by 64 is 16, which is indeed 4 squared. In general, whenever you divide powers with the same base, so these two powers have the same base of 4, then you can subtract their exponents. Try another example. Say you're dividing 3 to the 17th power by 3 to the 11th power. This equals 3 raised to what power? Precisely, 17 minus 11 is 6, so this quotient equals 3 to the 6th power. Okay, for your final challenge, here are 2 more equations, and each has a missing exponent. See if you can figure out what those exponents are. And remember that whenever you see a number without an exponent, like this 6 over here, that's the same thing as saying 6 to the 1st power. Okay, now find those exponents. Excellent. So you can think of this 6 over here as being 6 to the 1st power. That means this exponent down here is 4, because 5 minus 4 equals 1. And over here, you are looking for a number that you could subtract 3 from and leave you with 8. And that number is 11. So again, nicely done. Just as multiplying powers with the same base means you add their exponents, dividing powers means you subtract their exponents.